derivatives of trig functions, and now we are also gonna look at the integral of trig function. I need to tell you here that I could not find any year. Going through past questions, I couldn't find any year where question was not given under this topic. For every year, you always find questions on integral of trig functions towards the end. I have been emphasizing that most of the time students don't have enough time to get towards the end of JAMB. So the questions that are always towards the end are always very easy. But due to the fact that some of the topics that are covered in those aspects are not most of the time being taught, so students don't even bother to look at them. But the questions there are always very easy. You're gonna see as we begin to treat past JAMB questions here. So you need to know basically 4 different expressions. I'm going to give you those expressions now, and if you're smart enough, I also used to say it that you are free to bring in your 4-figure table. Well, I don't know the situation now, but during my time, you are absolutely free. You have the right to bring in 4-figure table. And most of these expressions are inside the 4-figure table. If you are like me, that you don't like cramming things, so you can always check them up in your 4-figure table. But make sure you don't write anything on your 4-figure table, okay? When you are taking the table into the exam hall, make sure nothing is written inside it. So let's look at those expressions that you need to know. So let me say importance formulae. Let me just put it like that. Important one. So the first one is if dy dx is equals to cos x, the integral of cos s is equals to sin x plus c. That is the first one. The second one that you should note is that if dy dx is equals to sine x, y, that is the integral of y, the integral of dy dx, which will give you y, is equals to minus cos x plus c. Number 3, if dy dx is equals to sec squared x, then y is equals to tan x plus c. And finally, if dy dx is equals to 1 over x, then y is equals to ln x. So you need these basic formulae or expressions to be able to solve any question under this topic. And I also have to add that in addition to these 4 expressions, you also need to know other trig expression, such as cos squared x plus sine squared x is equals to 1, tan is sine over cos, things like that. You need to know all of them. So I'm going to be applying them as we move on. So in this lecture, it is assumed that you are familiar with all these trig expressions. So without any delay, I'm gonna look at some questions and see what is expected of you to do in JAMB. So, example 1. So I'm going to take this example from a JAMB past question, and let us see how the question goes. Example 1, the question is okay, I need to put the year. Okay, so the question is 1998, JAMB question 1998, UME 1998. So it goes thus: evaluate integral of 0 to pi over 4 sine x minus cos x dx. So our ScoreBooster solution goes thus. So I will just say let's y be equals to integral of pi over 4 sine x minus cos x dx, right? So there is no difference between derivative and integration, differentiation and integration when it comes to the issue of sum rule. So we have 2 terms, 1, 2. So we are going to integrate this one separately and integrate this one separately. Okay, so applying the rules I have told you. So let's go back and see it together. We are going to integrate sine x. We are going to integrate cos x. So the integral of sine x is minus cos s, and the integral of cos x is what? Sine x. That is clear. So let's go to it. So this is still going to be 0 to 4. So if you integrate this one, you have minus cos x minus integrate cos s, you have sine x. Then you have 0 and 4. I hope there is no issue with this. Everybody understand. So now, depending on you, you should know that. Let me just take this one. You know that when we say pi, it means 180 degree, right? So what do you expect pi over 4 to be? Pi over 4 means 180 over 4, and that will be what? 45 degree. So just I want you to also take a good note of that. So we go here, this will be equals to, you're going to use the limits. So I'm gonna have, let me have cos 0, which is 1 minus 1, cos 0 is 1, and my sine 0 is 0. I hope this is clear. So if you simplify what we have here, you're going to have minus 2 over root 2 plus 1. Okay, and again, the fact that this question is simple, JAMB will want to put you in a tight corner by trying to play with the options that they are going to give you. So for this question, you don't have this as one of the options. So JAMB still wants you to utilize your knowledge of sorts. So we are going to see what we are going to do to rationalize this. So if you find the LCM, you can still put this question in this form, minus 2 over root 2. Okay, so find the LCM and just add and subtract and interchange things. This is not gonna be a big problem. So in continuation of that, what you have now, let me rewrite what I have there. So you have what we have is root 2 minus 2 over root 2. So you rationalize this one, okay, make it multiply by 1, and 1 is the same thing as root 2 over root 2. So you are going to have root 2 times root 2, that will give you 2 minus 2 root 2 over root 2 times root 2 is 2. And this will give you, this will give you 2 into 1 minus root 2 over 2. And your final answer is 1 minus root 2. Can you imagine that? So you still have to go a bit further after getting your answer to get the correct option. I hope this is clear. All right. So let me take one more example. Example 2. Example 2. So example 2 still gonna be a JAMB question, and this time it's gonna be question from year 2000, year 2000, number 43. So UME 2000. So the question is find integral 0 to pi of cos squared theta minus 1 over sin squared theta d theta. I know in Nigeria we call it theta. Please permit me to call it theta. Okay. So let's look at what's the solution look like. So I'm going to write y is equals to integral of pi cos squared theta minus 1 over sin squared theta d theta. Now You know, somebody say average mathematician is lazy. It's not an abuse, okay? What they are saying is that mathematicians always look for way to make things easy, rather than you integrating this, integrating this one. And so all you need to do is just think of something that will make your life easy. Why not look at this question this way? Sine squared theta plus cos squared theta is equals to 1. Do you agree with this? You can quickly see that from here I can get this. How? Okay, let's see. I can say sine squared theta is equals to 1 minus cos squared theta. Now, in order to put this expression in this form, so I'm going to have minus sine squared theta is equals to cos squared theta minus 1. I hope you agree with this. So I just multiply both sides by minus 1. This one becomes minus, this one becomes minus, that's why it is here, and this one becomes plus, that's why it's here. So this is plus. Okay, so I can now substitute this expression if you compare this and this. So I can remove this one and put this. Okay, therefore y will be equals to integral of 0 to pi of minus sine squared theta over sine squared theta d theta. You can see our life is now very simple. So sine squared theta cancel sine squared theta, we're going to have 1. The meaning is that y is equals to integral of 0 to pi minus 1 d theta. I have to write this minus 1 so that you could understand. I could have written it as minus d theta, thinking that you will know that what is here is 1. At any rate, this is okay. Now, go back to your law of indices. I can say theta raised to power 0 is 1. Do you agree? This is not degree. This is theta raised to power 0. Because we said in indices that whatever raised to power 0 is 1. So the meaning is that I can come here and write minus theta raised to power 0 d theta. If I want to integrate whatever raised to power 0, I'm going to add 1 to 0 and divide it by 1 plus 0. The meaning is that the derivative, the integral of minus theta raised to power 0 is theta, 0 and pi. I want to believe that up till this moment, everything is still clear. If you like, you can bring out this minus and have theta inside the bracket, and you have pi. So now you have minus into, I want to be consistent. Okay, so minus into pi minus 0. That is when pi is equals to, when theta is equals to pi and when theta is equals to 0. So what do you get? We have minus pi, because pi minus 0 is 0. So this is your final answer according to what you have as the options. Give me some time, let me take some tea, okay? Thank you. I hope this is clear. I'll take one more question, then over to you to try your hands on some exercise. So number 3, example 3. This is UME. Which year is that? Oh, couldn't get it. Perhaps I'm gonna find that later, but I think it's recent year, maybe 2015, I guess. 2015. It's a very recent question. Just give me some time to check out this. I want to be sure. Okay, it's not that important, but this is a jam question and couldn't remember the year. So the question is, find integral of okay, this is sine x plus 2 dx. You can see this is a simple one. So what is our solution? So our solution goes thus: y is equals to integral. I hope you are not surprised. My previous video, I did both definite and indefinite integral. So this is indefinite integral. You don't need to substitute anything. You are not given the limit, so you just make it free. So this is sum rule, right? You're gonna integrate this and you're gonna integrate this one. So if you integrate sine x, you're gonna get cos x, plus if you integrate 2, you're gonna get 2x. Let me take some time to explain this. Now 2 is the same thing as 2x raised to power 0. Understand? Because anything raised to power 0 is 1, and 2 times 1 is 1. So that is why 2x raised to power 0 is 2, right? And if I integrate this one, it's gonna be 2x 0 plus 1 over 0 plus 1. At the end, I'm gonna have 2. I'm gonna have x. 0 plus 1 is 1 over 1. No need to write this one. This one and this one, no need to write it. That's why I have this one. Then plus a constant that we don't know. Can you believe this? This is the answer. Final. So if you can master this aspect of integration, it means you are sure of getting 1 of the marks out of 50. So I believe with these 3 examples, you will be able to deal with any question that come on your way. So let me give you some exercise to work with, and I believe you won't find any of these exercises difficult.